5, 6 radical functions. So with these radical functions, we have functions, which means we are graphing these, that have either square roots or cube roots. When we have square roots that we are graphing, they look like this top one here, where it starts at your origin, and it goes either up or down, right or left, and there's a curve there. For your cube root functions, they look like an S that goes through any x value on your x-axis. If we look at the first set of examples, we are just graphing the following functions and stating the domain and range. Your domain, whenever you're working with your square root functions, is always your 0, infinity. X is always greater than or equal to 0. It also depends on what kind of function you have there. With your cube root functions, it's always going to be all real numbers for your domain. Your range for your square root functions is your 0, infinity, and y is greater than or equal to 0. Then your range, same thing with that one, it depends on your y values. Your range for your cube root functions are also all real numbers. So if we look at example A, we have f of x is equal to the square root of x. We are going to plug in these x values for x to get our y values. So if we do the square root of -1, that's no solution. We're not going to have a y value for that. So this is not an ordered pair that we're going to use. The square root of 0 is 0, so that's the ordered pair 0, 0. The square root of 1 is 1, so that's the ordered pair 1, 1. The square root of 4 is 2, so that's the ordered pair 4, 2. And the square root of 9 is 3, so that's the ordered pair 9, 3. When we go to graph these, we're going to have a point on 0, 0. We have 1, 1. We have 4, 2, and then 9, 3. And we just draw our line through those points, and then we're done. For our cube root functions, we have -12, -5, -4, -3, and 4. For -12, we're going to plug that in. We're going to have 4 times the cube root of -12 plus 4. That's the cube root of -8. That's 4 times -2, which is -8. So this is going to be the ordered pair -12, -8. For the 5, we're going to have 5 times the cube root of -5 plus 4. That's the cube root of -1, which is -1, so that's 4 times -1. That's -4. So that's going to be the ordered pair -5, -4. For -4, we have 4 times the cube root of -4 plus 4. That's 0. The cube root of 0 is 0, so 4 times 0 is 0. That's the ordered pair -4, 0. For the -3, we have 4 times the cube root of -3 plus 4, which is the cube root of 1, and that's 1, so 4 times 1 is 4. That's the ordered pair -3, 4. For 4, we have 4 times the cube root of 4 plus 4. That's 8. The cube root of 8 is 2. 4 times 2 is 8. So that's the ordered pair 4, 8. If we go to graph these, we have our first ordered pair, which is -12, -8. That is going to be off your coordinate plane somewhere over here. Your -5, -4 is here. Then we have -4, 0, which is here. And then -3, -4. Oh my goodness, I'm not doing this right. Pay attention. Alright, so -5, -4 is here. Then -4, 0 is here. Then we have -3, 4, which is up here. And then 4, 0, 4, 8, which is here. So if we look, our graph does this curve, or our line does this curve. So if we look here, we can see very easily that our domain and range are all real numbers. What are your domains are your x values. So what x values are covered? Well, your arrow suggests that this line goes all the way to the right and all the way to the left, from -infinity to +infinity. So our domain is -infinity, +infinity. Our range, those are those y values. Again, that arrow goes to the left and right, which also includes it going up and down to infinity. So this is going to be -infinity, +infinity as well. If we look back at our square root function, we are starting at 0 for those x values and going to the right. So it's literally from 0, and it includes 0, so it's going to be a bracket. Oops, this is domain. This is going to be 0, comma, and it goes to infinity, so it's going to be comma, infinity, and then a parentheses, because that means that it does not necessarily include infinity. It can go beyond. The 0 has a bracket on it because it includes 0. It is 0. It does no less than 0. Your range, in this case, is the same thing. We have our lowest point of 0 on our y-axis, and it goes up from there. So it's going to be 0, comma, infinity, with the bracket on the 0 and the parentheses on the infinity. For our next example, we have the cube root of x. So the cube root of negative 27 is negative 3. The cube root of negative 8 is negative 2. The cube root of 0 is 0. The cube root of 8 is 2. And the cube root of 27 is 3. So these are the ordered pairs: negative 27, negative 3, negative 8, 2, 0, 0, 8, 2, and 27, 3. So if we graph these, we're going to start with that negative 8, 2, which is here. Then we have 0, 0, and positive 8, 2. Oh, sorry, this is negative 2. So this one should have been here. And then this one is up. So this is going this way. This one's going this way. So this one's a bit wider. But again, your domain is all real numbers. You could also write it like this. Your range is also all real numbers. You can write it there too. Okay, it goes right to left to infinity, from negative infinity to positive infinity, and up and down from negative infinity to positive infinity. If we look at example D, we have the square root of 8x plus 1. For negative 2, that's the square root of negative 2 plus 1, which is the square root of negative 1, which is no solution. So this is not going to be one that we work with. For the negative 1, we're going to have negative 1 plus 1 underneath the radical. That's the square root of 0, which is 0. So that's going to be the ordered pair negative 1, 0. For 0, we plug that into our radical. We have the square root of 0 plus 1. That's the square root of 1, which is 1. So that's the ordered pair 0, 1. For 3, we plug that in. We have the square root of 3 plus 1. That's the square root of 4, which is 2. So that's 3, 2. And then for the square root of 8 plus 1, that's the square root of 9. That's 3. So that's the ordered pair 8, 3. So when we go to graph these, the negative 1, 0 is what we're starting with. That's going to be here on our x-axis. Then we have 0, 1, 3, 2, and 8, 3. So look now for your domain. What are your lowest x values that are covered? Your lowest x values that are covered are negative 1. So x is greater than or equal to negative 1. You could also write this as, because it's greater than, you're going to have a bracket on the negative 1, and then it's going to go to infinity. So parentheses on the infinity. For your range, look at the values for your y's. Your lowest is that 0. So y is greater than or equal to 0. You can also write it as a bracket, 0, comma, infinity, parentheses. With these square root functions and cube root functions, we have transformations. For these transformations, we are literally using a formula. So if we have something like the square root or cube root, and then outside of it, it's plus or minus a number, it's going up or down. If it's plus a number, it's going up. If it's minus a number, it goes down. If it's underneath the radical, it means it's going either right or left. If it's minus a number, think opposite, it's going to go to the right. If it's plus a number, it's going to go to the left. Again, that's underneath the radical. For vertical stretches and compressions, that's a number right in front. It's like the coefficient of that radical. If it is a whole number, we're doing a vertical stretch. If it's a fraction, it's a compression, so it gets smaller. So underneath the radical, again, opposite, that's your horizontal stretch or compression. If you have a coefficient of x and it's a fraction, you're going to stretch. If it's a whole number, you're going to get smaller, so you're going to compress. Your reflections are either across the x or the y-axis. If it's outside of the radical, it's across the x-axis. If it's inside, in front of the x, it's across the y-axis. Now, with these, when I teach it, I like to make sure that you think whatever's underneath is opposite. So whatever's underneath is opposite of what you would think, just like the left or right. If it's negative, you would automatically think it goes left, but in reality, it doesn't. It goes right. So it's opposite of what you would think. Just like with those fractions or whole numbers. If there's a fraction in front of a number, normally it gets smaller, but if it's underneath the radical, it's actually going to get larger. And then with the negatives, you just have to make sure that you remember that anything that you are doing underneath, if it's a negative in front of the x, it's across the y-axis. Think about it. All of these things underneath that's happening is going side to side. So if you're going side to side, what axis would you be crossing? Your y-axis. For some of these examples, we are using f of x as a guide, and f of x is just the square root of x. And we are describing the transformations here. So if we look at the first example, we have g of x is equal to the square root of x minus 2. That minus 2 is outside the radical, so because this minus 2 is outside, it's going to go down 2. For b, we have 3 times the square root of x. Because that 3 is in front, think normal. It's a whole number, so it's going to get larger. So that's a vertical stretch by a factor of 3. Oops. For c, we have g of x is equal to the square root of x plus 1. That plus 1 is on the outside, so that means that we're going to go up 1. For g of x is equal to 1/2 square root x. That 1/2 is outside the radical, so it's in front. Think just like it is. It's a small number. It's a fraction, so you think smaller. So this is going to be a vertical compression by a factor of 1/2. For e, you have g of x is equal to the square root of x plus 4. That plus 4 is underneath the radical. So think opposite. It's positive 4, so think the opposite of that is negative. That means it would go to the left. So this is left 4 units. For f, we have a negative times the square root of x. The negative out front just means that it's reflecting. It's out front, so you're going up and down. When you go up and down, you reflect across the x-axis. So this is a reflection across the x-axis. For g, we have 2 times the square root of x plus 3. That 2 out front, whole number, think like it is, bigger. So this is going to get larger. So that's a vertical stretch by a factor of 2. And then that minus 3, let's do this in a different color. That minus 3 underneath just means that you're going side to side. Think opposite since it's underneath, so we're going to go to the left 3 units. For h, we have a square root of negative x minus 2. That negative underneath is a reflection. Now, if it's underneath, it goes side to side, so it would reflect across the y-axis. That minus 2 underneath is going to be left or right, opposite since it's underneath, so left is negative. Think opposite, so right 2 units. For I, we have g of x is equal to the square root of negative x plus 3. The negative underneath deals with a reflection. It's underneath, so right or left, it reflects across the y-axis. And then that plus 3 is on the outside, so it's going to go up 3 units. for j, we have g of x is equal to negative 3 times the square root of x minus 1. So there's 3 transformations here. The first is that negative on the outside. That means up or down, so it'll cross the x-axis. Reflect across x-axis. Then that 3 is on the outside, so keep it the way it is. 3 is a larger number, so it gets bigger. So that's a vertical stretch by a factor of 3. And then that minus 1 is going to be going down 1 unit because it's on the outside. So this formula here pretty much tells you exactly what to expect. So if you have a number outside the radical, you take the vertical stretch or compression of the factor. If you have a fraction or a number inside the radical, in front of x, that means it's a horizontal stretch or compression. Then you have your horizontal transformations side to side, left or right, or your vertical transformations up or down. If we look at example 3a, we have to use the description to write the square foot function of g. So we're going to start with f of x is equal to the square root of x. We're going to start with the square root of x. It says that it is stretched horizontally. If it's horizontal, that means side to side. So that's underneath the radical. We're going to take the opposite or the reciprocal of what we have by a factor of 2. So that's going to go in front of the x, and that's going to be 1/2 in front of the x underneath the radical. Then we have a reflection across the y-axis. Y-axis, again, is reflecting across, is going side to side, so that's going to go underneath the radical. So this is going to turn into the square root of negative 1/2 x. And then we're translating 3 units to the left. So the left means underneath, so that's going to be opposite of 3. Opposite of what you would think, so left would be negative. Instead, it's going to be positive, so plus 3. So our solution here, our function is g of x is equal to the square root of negative 1/2 x plus 3, all underneath the radical. Now, when you do this, you have to make sure you put that g of x in front of your function, okay? If we look at b, we have the parent function of f of x is equal to the square root of x. So we're going to start with f of x is equal to the square root of x. Is reflected across the x-axis. So x-axis is up and down reflecting across it, so it's going to go in front of the square root. Then we're stretching vertically. Vertical is up and down. It's going to go in front by a factor of 2. Keep the 2 a 2. So that's going to be negative 2 times the square root of x. And then we are translating 1 unit up. So that means we are going up 1 unit. It's going to be on the outside. It's going to be plus 1. So it's just the g of x is equal to negative 2 times the square root of x plus 1.